All right, so in Chapter 3, Section 1, we're going to start by talking about simple interest. So you may remember from a previous math class or something else that you would see a formula for simple interest would look something like I equals P times R times T, where I is your interest, P is your principal, R is your annual interest rate, and T is your time. Turns out that's great for mathematics, and that is not the convention used in business. Business has the convention of using multi-letters grouped together to represent variables. So in almost any book on finance, instead of seeing just I, you're going to see INT for the interest. So for our interest, the variable is INT, and for our starting amount or our principal, in finance books they use the principal or the present value for the principal. And for its variable, they will use PV. When we see R in a book on finance, R will always be the annual interest rate, or the interest rate per year. And T will be time. And in this format, it will be in years. So the reason I mention that is we need to be aware of the fact that PV isn't two variables. It's P, and it's the principal or the present value, right? So when I write PVR, something like this, PV, this is one variable, so this is the present value. And the R is the interest rate, right? In math, that's not the normal convention. If I wrote PVR, if you were in a math class, you would think that was P times V times R. So we're going to have to be careful and aware that in all of these finance formulas, we're going to have variables that are represented by more than one letter. So INT is your interest, PV is present value. We'll see some later for payments and other things like that, and I'll always introduce those symbols. So just make sure to keep that straight, because for me as a mathematician, that really messes with my head because I want them all to be separate variables. But that's just the way it is. So when you look in a business book or a book on financial mathematics, that's exactly what we're going to see. So simple interest is your present value, so how much money you have now, times your annual interest rate, times your time, with all of these things measured in years. So let's take a look at our very first example and remind us how we use this formula. So find the simple interest on a $30,000 investment earning 3% per year for 4 years. So the $30,000 is going to be our present value. And our interest rate, we can never use it as a percent. We must always convert it to a decimal. And it's going to be our R, and our time, T, is going to be the 4 years. So then using our formula, we have that our interest is going to be equal to our present value of $30,000 times our interest rate, which is 0.03, times our time, which is 4 years. And of course, I don't have my calculator. put that in, 30,000 times 0.03 times 4. And we get $3,600 in interest. So for our simple interest formula, $30,000 invested at 3% interest for 4 years would earn a total of $3,600. So let's take a look at our next example and do a little comparing and contrasting. So example 2 starts off almost identical to example 1. So find the simple interest on $30,000 invested at 3% per year, but this time notice our time discrepancy. It says in our time, which is for 4 months. As mentioned up here with our formula, our time was always measured in years, so we're going to do pretty much the same thing that we had before, but we have to be a little bit careful with our 4 months. So our 4 months in years, well, there are 12 months in a year, so we're going to have 4 over 12, which would reduce to 1/3. So then putting that in, we would have our interest would be our 30,000 times our 3%, but this time we would have to multiply that by 1/3, or 4/12 if you prefer. So putting all of that into our calculator, we have 30,000 times 0.03 times our 1/3, and we would get $300. So we would earn $300 in interest for 4 months. So this illustrates the idea that the simple interest formula that we're familiar with from college algebra and other things uses an annual interest rate. In finance and many other applications, it's often better to think about this formula in a slightly different way. So our current formula, as we mentioned, that we used is INT is our present value times our interest rate times T, where T is measured in years. And this is our annual interest rate. So that's our interest rate per year. Well, we can change this formula a little bit. So let's go ahead and instead of doing it this way, let's imagine we were going to rearrange this expression that we had here. So our present value was $30,000. Our interest rate per year was 3%, and our time was 1/3 or 4/12 of a year. So if we were to take that expression, and I'm going to go back to my 4/12, we could use some properties to rearrange these terms. So I have 30,000. I'm going to move the 12 over here, and then I'm going to leave the 4 here. When written this way, the 30,000 is still our present value, but what would the term 0.03 over 12 be? Well, 0.03 was our annual interest rate, so if you divide it by 12, this now becomes the monthly interest rate. And this represents the number of months. So this idea is a very specific case applying to that problem, but it can be generalized into a more general formula for simple interest. So a more common version of the simple interest formula is INT is equal to our present value times I times N. So in this, the I represents the interest rate per period, and the N represents the number of periods. So in that case, in terms of the previous problem, if we took 0.03 and divided it by 12, we would get that the monthly interest rate would have been 0.0025, or 1/4%, and the number of periods that we calculated the interest for would have been 4. So using that formula, we would get INT is equal to 30,000 times 0.0025 times our number of periods, which is 4, and we're going to get exactly the same answer. And we still get the $300 in interest. So the simple interest formula can be rewritten as this in a more general form, where I is the interest rate per any period, and N is the number of periods for which we are going to be charging that interest. All right. So the next thing we want to talk about is the future value and our symbol for future value is going to be FV, where our present value is PV. So the future value of an investment well, let's see if we can figure that out. Well, based on what we saw above, using this formula, we can calculate how much interest we had. Well, looking back at example 2, if I had $30,000 when I started earning 3% interest for 4 months, I earned $300 in interest. Well, how much money would I have total after those 4 months? Well, it would be my starting amount plus my interest. So our future value is going to be equal to our present value plus any interest that we earn. But we have a formula for our interest, right? So our future value is our present value plus our interest formula, which is PVRT. And then we would notice that we have a common factor of present value in each of these. So our future value would be equal to our present value, factoring that out, 1 plus R times T. So the future value of an investment is the present value times 1 plus the annual interest rate times the amount of time. In terms of our other formula, the future value is equal to our present value times 1 plus IN. And this one always drove me bonkers, because when I see IN, I think inches, but it's the interest rate per period times the number of periods. So that would be our formula for the future value of an investment with interest rate I per period times n periods. All right, let's go ahead and take a look at our next example, which is example number 3. So your child is going to need $3,000 to study abroad in 2 years. How much would need to be invested at 4% now to have enough money for the trip? All right, so to resolve this, we're going to be using the formulas we were just talking about. So if they're going to need $3,000 in 2 years, that's the future value, right? So our $3,000 that we see here is the future value of that investment, and we want to know, well, how much money do we need now? That's going to be the present value for us to be able to have $3,000 in 2 years if we invested at 4%. So using our formula, we have our future value is equal to our present value times 1 plus I times n. So the future value that we're looking for is 3,000. We know that we're going to want that in 2 years. So our interest rate is 4% per year times 2 years. So we can use this with either this being n and this being I. You will also note that this would have worked if we would have used the other formula because we're given an annual rate and we were given years. Either way, if you substitute them in, you get the same thing. So we're going to get the following equation. So we get 3,000 is equal to what we want, the present value, 1 plus, don't forget to turn our percent into a decimal, 0.04 times 2. So we get 3,000 is equal to our present value, and we have 1 plus 0.04 times 2 gives us 1.08. So to solve for our present value, we divide by 1.08 and we divide by 1.08, giving us 3,000 over 1.08. And we get $2,777.77. So rounding that to the nearest penny, we would need $2,777.78. So if you invested that today, in 2 years, at that interest scheme, you would have the $3,000 that you needed for your child to go study abroad. Okay, so that brings us to our first you try. All right. So let's go ahead and so we have that we're going to use our formula. Future value is equal to the present value times 1 plus I times n. So before we can use this formula, we have our interest rate per month is 0.25, and we have our number of months, or our periods, going to be 6. So we convert our percent into a decimal, which is 0.0025. And we want to know when the future value is 5,000. So that gives us our present value times 1 plus 0.0025 times 6. Feed that to our calculator. And so we have 1 plus 0.0025 times 6 gives us 1.015, so 5,000. We're going to have 5,000 equals 1.015 times our present value. And we divide. So our 5,000 divided by our answer gives us $4,926.11. And rounding to 11 cents. So we would have paid $4,926.11 for that bond, for it to be worth $5,000 after 6 months.
For the months, we don't divide it by 12.
Go out something else. So the calculations that we've been doing, we want to find the present value for a known future value. So in general, we had our formula that our future value was equal to the present value times 1 plus I times n. Well, instead of doing the computation one at a time like what we were doing in the previous problems, we can actually just solve for the present value. So the present value for simple interest is present value PV is equal to the future value divided by 1 plus IN. I mean, we were using algebra to solve for that, but there's no reason to have to go through that every single time when we can just use a formula for the present value. This also has the equivalent form given in annual terms. It's our future value divided by 1 plus our R times our T.
Can you say again what the difference of the two equations is, please?
And maturity value. So the maturity value of a T-bill is the amount of money it will pay at the end of its life. Which is really what they mean is upon maturity. So the maturity value is the value that a T-bill or another investment device will be worth when it reaches the end of its life, when payment is due. So the cost of a T-bill is less than its maturity value. So the T-bill is sold at a discount. And the discount rate is the annualized percentage of this discount. All right, so armed with these definitions, we are now ready to do our example. So, example 4, a T-bill paying $10,000 after 6 months sells at a discount rate of 3.6%. What does it sell for, and what is the annual yield? So the first thing that we need to take into account is when they say it sells at a discount rate of 3.6%, that means that is the annualized percentage. So, since this is a 6-month T-bill, is 6 months, or 1/2 of a year, right? So, the actual discount is half of that, so 3.6% divided by 2, so 1.8%. So then the selling price is the price, so $10,000 minus $10,000 times the actual discount. So as a percent, as a decimal, we get 0.018. So we go 10,000 minus 10,000 times 0.018. And we get 9,820. Well, that would be our selling price. And then, well, what would be the annual yield of that T-bill? Well, we could use our same formula. So the future value is equal to the present value times 1 plus R times T. And the reason we're using this formula is, remember, R is always the annual interest rate and T is time. So if we put in our values that we have, and remember 6 months, if T has to be in years, we're going to have to use T equals 1/2. So our future value is going to be the value. Present value is 9,820 times 1 plus r, we don't know, times t, which is a half. So we're going to have 1/2 times r. And then we want to solve this equation for r. So we divide by 9,820, and we divide by 9,820. Let's just keep a running calculation. 10,000 divided by 9,820 gives us 500 over 491 is equal to 1 plus 1/2 r. So we minus 1, we minus 1. And something that's nice about our TI calculator is if I just go minus 1, it automatically pulls up the answer from the previous line and subtracts 1 from it. So I get 9 over 491. So then to solve for r, I multiply by 2, I multiply by 2. And I go times 2, and I get this. And then I don't want a fraction, I want a decimal, so I hit my math key, choose choice number 2 for decimal, and I get 0.03665, so forth, for r. So we would get approximately 3.67. So the T-bill pays 3.67% annual interest.